So what I doing today is like I'll take Zahana marked attendance. So today we will revise what all things we have gone through in our last class. So I hope you can see my screen and I am audible. So yesterday, the last class we discussed about stones and we discussed about the type of stones, where it is used, etc. And the classification of stones based on geological classification, physical and chemical classification. So as per geological classification, stones are divided into three types. The rocks are divided into three types: igneous, sedimentary, and metamorphic rocks. So igneous rocks are formed as a result of cooling of magma after a volcanic eruption happens, and there are some examples given for it. And it's still divided into three subdivisions: plutonic rocks, hyperbasal, and volcanic rocks, based on the depth at which you can find the igneous rocks. So plutonic rocks will be formed at a considerable depth and will be coarse grained and crystalline. Hyperbasal will be formed at a shallow depth, fine grained and crystalline. And the volcanic rocks will be formed on the Earth's surface. And next is the sedimentary rocks. The sedimentary rocks will be formed as a result of the deposition of small sand particles as a result of frost, rain, wind, etc. And they might be subjected to heat and pressure, and they will get consolidated and with sedimentary rocks will be formed. A typical example is actually limestone, sandstone, etc. And the third type based on geological classification is the metamorphic rocks, in which these igneous and sedimentary rocks, when they undergo some changes due to internal pressure and chemical action, etc., when heat can also change their properties, you will get metamorphic rocks. And examples are given when limestone will get converted to marble under the action of heat, internal pressure, and other chemical action. Similarly, sandstone will get converted to quartzites. So this is the geological classification, and next we have seen the types of igneous rocks based on the depth of its availability. We have seen that figure, and the next classification was based on the chemical classification, based on the chemical composition of the constituent matter. And first was siliceous rocks, second type was argillaceous rocks, and third was calcareous rocks. So we have some examples for each one. For the first one, the example is granite, quartz, etc. The second one is laterite. Laterite, I hope you have understood. I've discussed about laterite in one of the previous classes we had done. I've shown you the images also. So I hope you have understood what's meant by laterite. And third classification is limestone, calcareous rocks, in which the calcium carbonate is the predominant matter, and the examples are limestone and marbles. And the third classification was based on the physical structure of the rocks, and it was divided as stratified, unstratified, and foliated rocks. The stratified rocks are where these rocks have a plane of cleavage or stratification and can split up along these planes. So I've shown you the images also. So in this stratified rocks, what happens is like we take a small piece of stone, this of less dense, that you can see that stratified layers, because each layer will be of higher thickness. So each layer might be of like 3 to 5 to 10 millimeter thick for the stratified rocks. And for unstratified rocks, it's basically a crystalline or granular, and it will be compacted. It won't be stratified. Stratified means it won't be layers. And next is foliated rocks. And this foliated rocks is actually an example for metamorphic rocks. All metamorphic rocks comes under a foliated category, in which this, even though this it is stratified into layers, if we take a small layer, a small rock, there's a high chance that we can see that small stratified layers. So this is actually a metamorphic rock. So the typical example we discussed was about marble. So you can see there are some design. There might be some designs in marbles. So those designs are as a result of this foliation process happened in metamorphic rocks. And these are the physical classification. And the stratified rocks will come under sediment rocks will come under stratified category. Similarly, all igneous rocks will be unstratified because they will be they are not formed. Igneous rocks are not formed as a result of any uh, sedimentation process, etc. So they are instantly produced, and they'll be granular or compact crystalline in nature. So this is the classification, third classification. And next thing we discussed was regarding the qualities of good building stone. So what are the qualities a good building stone should possess in order to use that for construction activity? So for a good structural stone, crushing strength should be greater than 100 megapascal or 100 Newton per mm square. So you need to understand that. So you need to understand that this structural stone means those stones which we are used as to transfer the loads safely foundation. As I have earlier said, the stones used in foundation, they are structural stones, and also the stones used in load-bearing walls, where there are no pillars or columns are available. The slab will be or the roof will be directly supported over walls, and in those places also we use the structural stone. Bricks are also used, but I was talking about when at what place the stones are used. Uh, in earlier days, in older days, medieval ages, we used to use uh, stones for walls. We didn't have the technology to produce molded clay bricks at that time, so it was a practice from that day to use these good quality stones as load bearing for the construction of load bearing walls. And nowadays, even nowadays, we are using laterite, and in some places still we use this granite stones for constructing walls, for load bearing walls. So the crushing strength should be greater than 100 MPa, and there are there's a small table given. So this table you need to write down only if questions are specifically about the crushing strength of stone, and if it's asked for some like 3 marks or 5 marks, you have to write this table as a word. But if a general question is asked, uh, like what are the qualities of good building stones, then you just have to write down what is the minimum strength required. That's the value 100 Newton per meter square. So yeah, this is the thing you should follow. And next, good property for a good building stone is actually the appearance. So how a good building stone should be is like it should be uniform in color, and it should be free from any clay holes, spots, or other colors. So the color uniformity should be there, and it should be free from any other clay holes or spots of any other bands, etc. That is the condition regarding appearance of good building stone. And next is actually the durability. So a good building stone should be durable. For making stones durable, they should be arranged in such a way that bed should be perpendicular to the direction of load. So this is the method by which we are constructing load-bearing walls. You have seen how these stones are laid. Uh, it's not laid in any tilted angle or tilted way. All the walls are constructed in vertical direction, such that the load or the what we can say, the bed of the rock or the surface of the rock is actually purely perpendicular to the direction of the load. So in that direction, our stones will have maximum crushing strength. But if you tilt the stone in any other direction, if you are placing it in any other direction, the crushing strength can reduce drastically. So that's the reason why these stones are placed always in a vertical manner, such that the surface is actually purely perpendicular to the direction of load. So direction of load is always vertical in the direction of gravity. You all know that. So we place. Pranav, could you please mute your mouth, mute your mic? Pranav, These kind of things you should avoid while taking class. So that means Pranav is not listening to other class, and I'm going to mark absent for you. So Pranav, if you can hear my voice, please mute your mic. Can anyone message him personally? So Pranav, can you hear me now? Pranav, could you please respond to my question? Can you see me now? Can you hear me now? So anyway, it will be marked absent for Pranav because I don't think he's inside home. You can hear the noise of some vehicles roaming around. So it's not actually recommended to roam around anywhere and listen to the class. You should be sitting in home while the online classes are being conducted. Okay, so I'll mark absent for you. So we were talking about durability, and in order to achieve durability, the stone should be arranged in such a way that the bed should be perpendicular direction down. And this is a facial gem dressing. Dressing, that means it should the stones we should be able to cut the stones into record size and shape. And next is a sharp or a fracture. That means the stone should be sharp. The edges should be sharp. It should be even bright, and the grains should be well cemented together. That means it should not be loose like limestone. We can't use limestone actually for construction purpose because it is not any sedimentary rocks cannot be used for construction purpose because the grains will be loose in nature. So this is the property regarding fracture. And next is the hardness. So the what's meant by hardness is like if we scratch that particular stone with our nail, it should if it makes a mark on that stone, then the hardness is actually quantified regarding the coefficient of that particular mark. So there are some numbers which define the hardness of a material based on the depth and size of the scratch mark that has been imparted on that particular material. For example, a diamond is actually the hardest non-material material known for common man. You'll know. So next is the percentage wear, and it is measured by attrition. So this is actually done in order so that we can use it particularly for any railway and road works because the railways and road, the stones will be subjected to continuous loads where continuous wear and tear, and it should be able to withstand this wear and tear for a long time. So the good building stone wear should be less than or equal to 3%. That means what happens is like this attrition test is actually performed in some civil labs where civil engineering labs you might not do that. It's actually done in some higher semesters. Students who are studying civil engineering, they will do it. It's actually a kind of a drum in which we will put some steel bolts and our stones into that, and then we will rotate it. So it will make a very uh, distracting noise. Makes a very sharp noise, just like a very bad machinery working. So the noise level will be too hard, and no one would like to go near that particular machine when it's operating. So what we'll do is like we'll just switch on that and we'll move aside and we'll move some distance far away because the noise made is like too disturbing for our ears. what happens is like inside that drum, they will continuously rotate and along with the steel balls that we put inside. And what happens is like it will be continuously subjected to wear and tear, and the stones will start to produce some small dust as a result of wear and tear from its surface. It will lose its surface smoothness, and then after some minutes we will take it out and we will remove the dust and we will measure. So that weight should not be more than 3% of the initial weight of the stone. That means the for a good building stone, the wear, that means the dust produced, should not be more than, as a result of this attrition dust, should not be more than 3% of the total weight. This is the thing regarding attrition test. I hope everyone have understood what I was trying to say. So this is actually a test performed in civil engineering labs. This will be done after we done by placing the stone, which we need to measure the hardness, uh, the percentage wear, along with some steel balls in a drum. It will be subjected to rotation at a particular speed, and then after some time we'll take out and we will measure the dust produced as a result of this attrition test, and that dust produced from the stones should not be more than 3% of the total weight of the stone that we have initially measured. So this is actually the percentage we are. And next is the resistance to fire. You need to understand that intervals composting stone should be such that the shape of the stone is preserved when a fire occurs. So limestone resists fire up to 800 degrees Celsius, and what happens is after that it will split into calcium oxide and carbon dioxide. So you have seen in many places, even the marble, which is actually a resultant when this limestone is subjected to heat, pressure, and the chemical action, that also splits when heated. So we can't heat marble more than a particular temperature. And also the thing is like it will be subjected to some chemical actions. Even atmospheric pollution can affect the durability of marbles, that we have seen in Taj Mahal, how the color of Taj Mahal um, has changed over the years due to the pollution from the surrounding cities. So next is the seasoning. Seasoning means we can't use stones that have been freshly cut and placed it. We should properly season it. And what seasoning means is like we should ensure that it doesn't take much moisture, uh, so that we can use it for our particular purpose. And next is specific gravity. So you all know what is meant by specific gravity. It's actually the weight. It's actually a number which relates with the specific gravity of water. The specific gravity of water is 1, and that means the building stone should have a minimum specific gravity 2 points. That means it should be 2.7 times heavier than that of same amount of water. So the specific gravity of steel is 7.85. We have several other materials like mercury, it is 13.6. So each material will have its own specific gravity. So for the stones which we intend to use for construction activities, the specific gravity should not be more than 2.7. What happens is like if the specific gravity is less than 2.7, then we need to assume that it has some porous means there are some holes or cavities inside this stone, and hence um, it cannot be used for main construction activities, like for construction of dams, retaining walls, etc. The basic thing is like the how it works is like the weight of the dam and the stones and concrete, etc., will act downwards and it will resist the lateral force applied by the water on it. So this lateral force of the water will be resisted by its own weight. Majority of its weight we can't resist by its own weight, and hence we can't. And it's necessary that we use stones of high specific gravity for such construction activities, where weight is actually a factor of resisting external load in case of dams and retaining walls. But in the case of roof covering domes, etc., so it's just done so that we can protect ourselves from small forces like wind, rain, etc. In that cases, it's not necessary that the weight is actually acting against the uh, weight is not the factor that actually acts against the external force. It's actually the shape and other structural behavior of that particular structure that acts against our external forces. So in that cases, we can use stones of with lesser specific gravity in case of roof covering domes, etc. So you might have seen the domes of most church, etc., where they are constructed. We won't generally use stones of high specific gravity because as the weight increases, it will be difficult for us to uh, balance the load distribution. But if it is of lightweight, and then we can easily give some supports and resist the external load also. And the texture, it should be compact, fine, crystalline structure free from cavities, cracks, or patches. And there are some roughness index. So remember just this. Remember these numbers. Roughness index is similar to impact. Impact means there is a difference between force and impact. When a force is applied suddenly, it becomes impact. So in case of roads, especially, there will be a huge impact, and also in case of some uh, places where sudden forces are expected, it is considered to be an impact. Whatever the cases, if you are designing a road or bridge, etc., we'll give an impact factor of 25%. That means we'll just multiply the load expected with 1.25 in some cases. And the impact factor will change depending upon several factors. You need not remember all this. I was talking about the term impact. That means if a normal force is applied in a given direction, and the same force when applied suddenly, it becomes an impact. So there will be some provisions for that sudden force, uh, and there are some toughness index. Then and its reaction to that impact is known as toughness. And there are some toughness index. There are some numbers. Based on that, you'll divide it into several factors. You just need to remember all those things. For better understanding only, I just talked about all those things. And next is the water absorption. And the percentage absorption by weight after 24 hours should not exceed 0.6%. So I think I've discussed about the same thing while I discussed about bricks, the percentage absorption of water. And the porosity will affect durability, because if the percentage absorption is more than 0.6%, you can assume that this will be highly porous. And as time progress, what happens is like this porosity, that means the cavities inside the stone, will start absorb moisture, and it can reduce the strength of the stone. It can alter the chemical composition or physical composition of the stone. Next is the weathering. So rain and wind cause a good loss of good appearance, and weathering resistant stone should be used for spacing works. So all the spacing works where we can directly see the facing walls or materials, it should not be affected by the good appearance should not be affected by rain and wind, and hence those weathering resistant stones should be used for such architectural or aesthetic purposes. So this is the thing that we all discussed about cement. So now, a minute. So we'll take the attendance of rest. So is Akib present? Akib Amin Tanri? Akib Amin? Abhinav Purushothaman? Abhinav present. So Abhirami KP?
Present, sir.
Ebin Devasya?
Present, sir.
Adarsh K?
Present, sir.
Adil?
Present, sir.
Ajal?
Present, sir.
Alan Joseph? Alan Joseph? Albert Tom George? Albert Tom George? Alina Gigi?
Present, sir.
Amal Binoy? Amal Binoy present. Ansel Sunny?
Present, sir.
Angel Thomas?
Present, sir.
Anjita Nambiar,
Present, sir.
Anne Sebastian,
Present, sir.
Anshi Shibraj,
Present, sir.
Anidan Jem,
Present, sir.
Ashwin M,
Present, sir.
Ashwin M. So Albert is
Present,
present.
sir.
Okay, Ashwin M is present. Ashwin K,
Present, sir.
Adulya T.
Present, sir.
Okay. So rest I'll take later. So otherwise, I don't want you guys to leave the class in between. There have been some cases and complaints that have been raised by many regarding the same. So I don't want you to do the same in my class. So the next thing we discussed yesterday was regarding cement. So we just started off with cement and what are the basic definition of cement. You know the basic definition of cement. So a cement is actually a powdery substance which is made by burning and crushing calcareous, that means those stones or material containing calcium as the main constant and argillaceous where clay is the main constant. And then what happens is like we mix this cement with water and it will a mortar will be formed, and this mortar can be used for several purposes. If it is applied for construction of walls, it can be applied for construction for the walls, bricks and stones, etc. And also, if we add sand and gravel, we what we'll look at can use concrete. So it is the most common used binding material. It's basically a binding material, such as a glue. What it does is like it will bind all its constituent particles together. So whatever things we add along with cement, it will bind them together. So that's why for construction activities, what we do is like we'll use cement instead of any other substances. So there are some properties of cement in this study, and we discuss about the history of cement. Who discovered it? Joseph Aspin is the person who discovered Portland cement, and why it is known as Portland cement because the at the time when he discovered it, the color was similar to that of a stone which is found in abundance in Portland, England. So that's why it's known as Portland cement. And the common variety of artificial cement is known as normal setting cement or ordinary cement. So it is the basic cement that we use, and there are some several additions and several new things that have come in ordinary Portland cement that we will discuss as we move on to the type of cements. So this ordinary cement is actually used for all the laboratory purposes. What happens is like for some research activities, all this ordinary Portland cement is used. But nowadays, no, very few people are using this ordinary cement for construction activities because there are some advancements that has happened in ordinary Portland cement where we add some special materials to it in order to change its properties according to our will. So there is some changes happening in construction industry. It's not recently, over the past several decades, all these things have been happening. And it's very difficult to even to find ordinary Portland cement in some stores. Yeah, it's very difficult. And all this we'll discuss about that in the coming slides. So what are the major sources of rocks? Calcareous rocks, which is basically limestone where we have calcium as the main constant particle, and next is the argillaceous rocks where this clay. You can see clay around that. This is some other material, so don't look into that. So the clay, you all know what is meant by clay. And so what we do is like we will mix them separately, and we will heat them. And what happens is like they will fuse to each other, and they will form a binding material so that we can whatever thing is added to it, it will bind it. So what are the main ingredients of ordinary cement? We are talking about ordinary cement. It's a basic cement that Joseph Aspin has discovered, as invented, not discovered, as invented. So there's a difference between discovery and invention. So discovery is actually is already present, and someone is going to explore that. Just like Columbus discovered America, we won't say Columbus invented America, but the same thing. What happens is like uh, Thomas Alva Edison invented a electric bulb. You can say like that. So there's a difference between invention and discovery. So at the time of invention of ordinary cement, the main ingredients are all those things, and several manufacturers, depending upon the availability of their raw materials, they will just change all these percentages slightly according to that. So if you find the common brands which are available, this is something like Ultratech, Chettinad cement, all those cements are very common, and there will be some difference in all these ingredients. However, it will be within that particular range. So we are talking about that range. And the first ingredient is actually calcium oxide, and the percentage is varies from 62 to 67 percentage. And we'll see what is the main function. The main function is actually contributes to the strength of the cement, and excess of lime will make the cement unsound. And what happens is like if we add excess of lime, cement will expand and it will disintegrate. And if it is deficient, what happens is like the cement will set quickly. What happens is like the setting of cement is actually controlled by calcium oxide and the reaction with water. So it's always necessary to add optimum amount of water. So water should not be too much more, or it should not be too less. If it is too less, what happens is like uh, all the particles, cement particles, will not get the enough water to set and this changes property, and it won't make a good mix. And also if the water is more, what happens is like it can cause some of the cement particles to just wash away. So the optimum amount of water should be maintained. Then you need to remember. And what happens is like if you someone asks you to prepare a cement mixture or a concrete mixture, what we can always do is like just add it's actually a handy thing. It's not I'm not talking about some scientifically designed or designed by a civil engineer. If some civil engineer is designing it, he will design according to the provisions given in the code. And there are several matters which come into picture. So you need not look into that. And if someone comes to you and just asks your engineering expertise regarding the same, you can just tell them that add uh, if 0.5 is the water cement ratio to be done. That means if we are taking 1 kilogram of cement, just add 500 milliliters of or 0.5 liters of water into that. So 0.5 liters is actually 0.5 kilogram of water. You know that the specific liter of water is 1000 gram per liter. So 1 liter will weigh 1 kilogram. So if you want to mix a proportion where we want to add 1 kilogram of cement, we can just add 0.5 liter of water in for 1 kilogram of sand, 1 kilogram of cement. So this is actually the rough mix, which we can use for any small other works. But if it's for very important works, these type of rough mixes won't work. So there are some several conditions that need to be considered for that particular water cement ratio. And I'm talking about your normal happenings. If there are some works in your garden, or if there is some small patchworks to be done, you can always use this water cement ratio. It's 0.5 liters for every 1 kilogram of cement. So and next constituent is actually, I was talking about the constituents, and next constituent is actually silica dioxide as AO2. But the percentage varies from 17 to 25 percentage, and all these manufacturers will try to keep within this limit, and it won't go beyond 25% in most cases. And what happens is like the function of silica is actually it imparts strength to cement due to the formation of dicalcium and tricalcium silicates. So you need to remember this dicalcium and tricalcium silicates. In the next slide, I've taught you the asthmas. So what happens if excess of silica is there? What happens is like it increases the strength, but its setting time is prolonged. So if we are adding excess of silica, what happens is like it won't set quickly. So that's the reason why there's a range is given. So there are, you might have seen some trucks carrying the cement, and they will be rotating. So all these things are ready mix concrete or available. And what happens is like these trucks carrying this concrete will be having a yard where this concrete is mixed, and they will be transported to sites. It might be several kilometers away. So in such cases, what they will do is like, in order to prolong a setting time. So if it is not prolonged, setting time is not prolonged, what happens is like, while transporting this, the concrete mix can get set. It will become hard, and it won't be able to use that. So it is necessary to reach the site as it is produced from the yard. So at that time you'll make some small changes on all these percentages, and also on the water cement ratio, and all some other chemicals will add to keep it wet until it reaches the site, all those things. So just don't go deep into that. That is, it's like an ocean. So if you dive into that, there's a lot of things to study. So just focus from the exam perspective of your computer science, the COPO mapping. That's known as COPO mapping, where your course outcomes should match with our program outcomes. So our program outcome doesn't expect computer science students to design a ready-mix concrete. So that's why it is taught in such a manner. So what we expect is you need to understand all these basic terms and other things. So just need to understand all those things. You not dive deep into subject. So if you dive deep into subject, it's like an ocean. Understand? So we won't be able to explore all those things. So next is next ingredient is actually alumina. It's L2O3, and what happens is it imparts quick setting property of cement. It acts as a flux and lowers the clinkering temperature. The clinkers I have talked, I will explain you in the next coming slides. And what happens is like, if we add excess quantity, it weakens the cement, and the strength of cement will get reduced. So these three are the main components, main ingredients of cement. And next ingredient is actually calcium sulfate. So these are less than 5%. Calcium sulfate will be 3 to 4%. So this ingredient is in the form of gypsum. It increases the initial setting time of cement. So all these constants will have a specific purpose. Some purpose is to provide hardness. Some purpose is to adjust the setting time of cement. Setting time of cement means at that time when it becomes hard. So there is some initial setting time, final setting time. There are some other things. I don't think you will have to study all those things. Just understand this. Calcium sulfate will increase the initial setting time. That means it will take some time to become hard if we add calcium sulfate with a higher percentage. Next is iron oxide. It will impact color, strength, and hardness, magnesium, sulfur, alkalis. So all these things will have its own specific purposes. So just remember all these percentages, all these ingredients, and this components or composition of ordinary cement is quite important from your exam point of view. You can expect questions as it is. So it's necessary to remember all these ingredient name and their percentages, and also their function. So next is actually we had discussed it, but I'll again discuss it in this class. It's actually the process, the dry process behind the production of cement. So this is the process most of the cement manufacturers rely. So what we do is like, we will take limestone and clay. Limestone, the calcareous material, and the herbaceous material, clay, and we will crush them separately, and then we will fine grind it in ball mills, so that it will become a small dust particles, the shape of small particles, and we will store it in the storage basin, and then depending upon the proportions, we will mix them in correct proportions. And what we do is that we preheat them by exhaust gases. Why we are preheating them is at 800 degrees is to remove any organic materials that might come along with raw material. There are chances that some small insects or some small other organic plants or something might come along with this raw material. So we'll preheat them at 800 degrees Celsius, and then what we'll do is like, we'll store them in some tanks, and then it will be fed to rotary kiln, and then it will be heated, and the heating temperature will be very high. So it can be more than 1000 degrees Celsius. And alongside we will after this heating is done, so the temperature will be around 1500 degrees Celsius, somewhere around that. And at that time clinkers will be formed. What means clinkers means there are actually the small ball shaped things which will be as a result of this mixing, small balls will be formed. And what we'll do is like we will again have to grind those balls into small particles. And at that time we'll just keep on adding gypsum at 2 to 3%. So we'll keep on add gypsum at that time. And what we'll do is like we'll grind the clinkers at that time, and then we will store it in silos. So have you seen silos? So silos is actually a thing you need to see. I'll just show that. So I hope you can see my screen. So these are the storage silos. They'll be near these manufacturing units. You can see. There will be a huge tanks. They will store the cement in silos, and then they will carry it and pack it. So these silos, these things will be stored in silos. So yeah, and then it will be sent for packing. So this is the manufacturing method of manufacturing cement, and this is the flow chart of the same. And if question is asked from this regard, you can answer it accordingly. So next is uh, compound composition of Portland cement. So this is actually a very important slide too. This is also a very important slide where we are going to discuss about box compounds. So at the time when I told you that some clinkers are formed. So after this rotary kiln, there's not a rotary kiln where we will mix this raw materials and we'll heat them with fuel. At that time, what happens is like some box compound will be formed, and there are four box compounds, and these box compounds are those compounds which will impart strength and initial setting time, all those things. So as a result of this mixing between a calcium oxide and the silica, those box compounds will be formed. So first box compound is tricalcium silicate, and the abbreviation is C3S. Form is 3CaSiO2. So the function of tricalcium silicate is to impart the initial strength to cement. So within age 7 to 28 days, initial strength is achieved. And next is dicalcium silicate. So dicalcium silicate is C2S as 2CaO SiO2, and it will impart strength at later stages, 1 to 2 years after the construction activity is done. It will impart the strength. The next is tricalcium aluminate is C3A, and tetracalcium aluminiferrate C4AF. So it provides rigidity. So within 24 hours, it will make the cement mix rigid after we mix it with water. So all these things functions will be performed only if we mix it with water. So that mixing of water is very important in case of cement. So you will understand that after C3S will impart strength after 7 to 28 days after we mix it with water, and C2S will impart strength at later stages after we mix it with water. So all those things. And the limestone C calcium oxide. All these abbreviations you can study. C means calcium oxide. So C3S means you can see C3CaO. That means it represents C3. SiO2 is represented by S. Similarly, all those things. So A is represented, the bauxite is represented as Al2O3, and hematite is represented as Fe2O3F. So all these compounds you need to study thoroughly. I hope you have understood until now. So I think I've taught you until this. So does anyone have any doubt regarding these two things that I've taught yesterday? I've just revised all those things once again. Hope it is clear. If anyone has any doubt regarding the same, you can ask me now. Can I proceed to our next topic, types of cement? Can I?
Yes, sir.
Okay. So before that, the same thing we need to do. I'm going to take attendance of some remaining students. I've called until Adulya, right? Now I'll start from Saranga Vinod,
Present, sir.
Sandesh Nambiar, Sandesh Nambiar, Sandesh Nambiar present. Sayant P,
Present, sir.
Pratwin,
Present, sir.
Pranav Sinesh. So Pranav is absent, as earlier I have expected. So Anaga Obi, Anaga.
Present, sir.
So Pranav, why didn't you answer that time? Are you inside your home or are you roaming around? Just reply by giving a message. Then
Yeah,
how did
sir. I was sitting in my balcony. My net was slow. I was not able to unmute.
okay? Then I heard some huge noises of vehicles.
Yes, sir. It was coming from outside. I was sitting in my balcony. My internet was slow.
Are you sure?
Yeah.
Okay. So I'm marking your attendance.
Okay.
Anaga Obi,
Present, sir.
Nigel P, Nigel P present. Neha,
Present, sir.
Naveen K Matthew, Naveen K Matthew, Nandana,
Present, sir.
Nachiketa Vishwashil,
Present, sir.
Mufas Mustafa,
Present, sir.
Mohammed Anzil,
Present, sir.
Matthew Abhijit, Maria Manoj.
Present, sir.
Okay. So then I will resume our class. Then I will take the rest of your attendance after some time. Then just to ensure that everyone is listening to my lecture, Northern Tensions. So we are going to start with the types of cement. So as I've explained earlier, this ordinary Portland cement was actually discovered in the start of this 19th century. And what happened was like uh, over the years, we had several other requirements, and we couldn't use the same type of cement for all our requirements. So what happened was like there was so many researches happening, and still now it's carrying on. And you can see every new every single year, a new type of cement is coming to market. Means there will be a difference in the constituents. There will be a small difference in the constituent. However, the function will be almost the same. And depending upon our requirements and the purpose, we will just change its properties. So hence there will be several types of cement will be available. So the first type of cement is actually the rapid hardening cement. So as per our Indian standard, Bureau of Indian Standards, Indian Standard Code 8041 1990. So the specification of this cement is actually mentioned in that particular code. The rapid hardening cement develops strength rapidly. The strength obtained by such cement at the age of 3 days is same as that expected of ordinary Portland cement at 7 days. So what happens is like we have something called as, you need to understand that the strength achievement of cement will increase as years proceed until up to 50 or 40 years from the time of construction. We can expect that the strength of that particular construction using cement will improve up to 40 years or 50 years. Then it will start reducing. So we have taken we will mention the strength at 28 days. Why? Because at 28 days, it will achieve nearly 97% of this expected strength. So beyond that, strength gain is very low. So until 40 years, 50 years, the graph will rise very slowly. But up to 28 days, there will be a progressive growth in the strength. And at 28 days, it will achieve nearly 96 or 97% of the expected strength. So beyond that, we won't consider the strength. And for all these design purposes and all these things, what we do is like we'll take the strength at 28 days from casting. That means at the 28 days of mixing with water and using it, we'll measure the strength. So that is known as the characteristic strength at 28 days. Even for concrete, we'll do the same thing. So and we need to understand that as days proceed, up to 40 years, even up to 40 years, the strength of something made with cement will increase. And after 40 years, it will start to decrease. So that's why most of the buildings has an expected life of 50 years or 75 years. So up to that time, you can expect an increase in strength. And when the strength goes below the expected one, we have to demolish them. So in this rapid hardening cement, so the strength obtained by rapid hardening cement at the end of 3 days will be equal to that of expected at the end of 7 days. So where we are using this rapid hardening cement is basically when we want to move the construction activity very quickly. So we can't wait until 7 days to remove the supports. You can see the supports given for these construction activities, especially if we are casting a slab, concrete or slab, etc. We can't wait till 7 days to remove all these things. So for that, if we want to proceed with the construction activity, we'll use this rapid hardening cement. So the rapid rate of development of strength is usually the higher fineness of grinding and the higher C3S and lower C2S content. So this is the thing I was talking about. The C3S and C2S are the box compounds, and its relative percentages in different percentages will be the criteria for the properties of this cement. So this rapid rate of development of strength will be due to the higher fineness of grinding. That means the cement will be more fine. It will achieve rapid strength. That means it can absorb more water earlier. So cement achieves strength by absorbing water and reacting it with water that we use for mixing. So at the end of what happens is like the higher C3S and lower C2S content will make it rapid hardening. So cement conformed the specifications Indian Standard 8041 1990. It is used for following circumstances. In prefabricated construction, road repair work, situations where formwork is required to be removed earlier. So in prefabricated constructions, is like we will cast something in the yard. For example, you can see the girders, that means the main beams for large bridges and metro works, will be cast in some yard and then they will be brought to site. So those things are known as prefabricated constructions, where the casting and the casting means I hope you understand what's meant by the casting of concrete. So this casting works will be happening in some other yards, and then it will be brought to the construction site and then it will be placed there. So that's known as prefabricated construction. So we can use this rapid hardening cement there. Then road repair works, because it is we can't expect our people to wait for the road construction activity to be completed. If it takes some time, we can't expect them to wait until that. So in those cases, we will use rapid hardening cement, where we can remove or we can open that particular road for public use very earlier than if you use that ordinary Portland cement. So in that cases, rapid hardening cement is used. And next case is what I've earlier explained, where the formwork is required to be removed earlier. Formwork means a support given for this construction or casting of concrete and all those things. You can see തട്ടടിക്കാൻ അറിയില്ലേ, നമ്മൾ താങ്ങ് കൊടുക്കുക തട്ടടയ്ക്കുക, അതൊക്കെയാണ് formwork എന്ന് പറയുന്നത്. So this formwork is required to be removed earlier than the expected date. You can use rapid hardened cement. So next type of cement is low heat Portland cement. So this is rapid hardened cement. This is low heat Portland cement, and this low heat Portland cement is mentioned in Indian Standard Code 12600 in 1989, which was published first in 1989. So where this low heat Portland cement is used, because you have to see when cement reacts with water, it is an exothermic reaction. It will it's what's meant by exothermic reaction. It will produce some heat as a result of this reaction, and this heat can harm its properties at some point. So this that's the reason why we use low heat Portland cement in some special occasions, not in all occasions, but in some special occasions where we can see in massive constructions like abutments, retaining walls, dams. Abutments means the supports that are given for these bridges. You can see that big structure, a big thing near to banks, where banks of river where the bridges are supported. So that's actually a massive construction where a lot of concrete is poured into that, and these retaining walls and also these dams. So in those cases, the temperature rises is an important factor, because this will therefore affect the water tightness of the structure and may lead to deterioration. So this temperature, if there's a massive concreting work, a massive structure is to be constructed, what happens is like if it's an exothermal reaction, it can produce heat, and hence it might make some cracks in that. So in that case, it is necessary to control the amount of heat produced in large, massive construction like dams, etc. So in that case, what happens is like you'll use low heat Portland cement. So in low heat cement, the heat involved is less. So the cement offers a better resistance to chemical deterioration than ordinary Portland cement. So it has a better resistance to chemical deterioration. Low heat cement is obtained by increasing the dicalcium silicate content, the C2S, and decreasing tricalcium silicate content, that is, we will decrease C3S, and we will considerably bring down tricalcium aluminate. C3AF, right? C3A, tricalcium aluminate. So this is the method by which while manufacturing low heat Portland cement, we will increase dicalcium silicate. That means we'll increase C2S, while we'll decrease C3S, and we will considerably bring down C3A. So just remember how these the constant percentages are changed in order to achieve this low heat Portland cement. So this cement is used for mass concrete works like construction of abutments, retaining walls, and dams, where a lot of concrete is required. Dam construction of a dam requires a lot of concrete to be poured in. So in that case, what happens is like it's not like a beam or a concrete wall or concrete column or pillar where the size is very small. In that case, the heat can escape your surrounding very quickly. But in case of large construction or massive construction activities where the size of that particular structure is very high, it is the heat produced at the interior regions uh, won't be able to escape properly, and it can cause some cracks and some internal water tightness issues, etc. So that's the reason why we use low heat Portland cement for massive construction activities. And next type of cement is Portland pozzolana cement. It's PPC. So it is this cement is the thing what we use nowadays for all the construction activities. So wherever you go, you can easily find these PPCs. And if you go to any hardware shops where they sell cement, you can request for PPCs, and they will have a huge stock of PPCs, and their ordinary Portland cement (OPC), that's known as ordinary Portland cement, that we had discussed earlier. That's a first cement that was produced, and the stock of OPC will be very less, and in some cases even they won't even have stock of OPC, because no one is going to use OPC nowadays. Many people rely on PPC, Portland pozzolana cement, and you can see where it is produced, where it is used. So it is according to the Indian Standard Specification IS 1489. So that's the name of the code. It was published in 1991. So Portland pozzolana cement is made either by intergrinding Portland cement clinkers and pozzolana. So pozzolana means, you need to understand, all those materials like burnt clay, shale, or fly ash. So fly ash is actually a result of this thermal power plants produce a large amount of fly ash. So there were a lot of researches was done. So where to dispose this fly ash. So only then at that time a lot of researches were done on cement, And people understood that if we use fly ash in cement, we can have two advantages. One, we can avoid the pollution as a result of dumping of fly ash in somewhere else. And next is like we can improve the properties of ordinary Portland cement. So from that time onwards, this fly ash and other burnt clay, shale, etc., like pozzolanic materials were used in ordinary Portland cement to make it as Portland pozzolana cement. So pozzolana may be a natural materials like volcanic ash or like fly ash, etc. The pozzolana content varies from 10 to 25% by weight of cement. So what we'll do is like we'll replace cement and we will add 10 to 25% of pozzolanic materials into that, depending upon our requirement, and that cement will be renamed as Portland pozzolanic cement. So free lime, which is readily attacked, are chemically removed. So that's the reason free lime, which is available in cement, CaO, will be readily attacked by chemicals. So whatever thing is there, or either any other acid attacks, CaO or calcium oxide in cement is the first thing which is subjected to attack. So that thing, CaO is readily removed, and we will replace that CaO with Portland pozzolanic. So pozzolana concretes have a greater resistance to chemical agencies. They can also resist attack by seawater better than ordinary Portland cement. Why? Because we have removed this calcium oxide. You all know how this calcium oxide is subject to attack from seawater or any other chemical agents, or even air pollution can attack calcium oxide. So the amount of calcium oxide in cement will be replaced with pozzolanic materials like fly ash or volcanic ash or burnt clay, etc. And we can increase the resistance of that particular cement against acid attacks or any other type of attacks. So it also has lower heat of evolution. So there are a lot of advantages for this Portland pozzolana cement when compared with ordinary Portland cement. So that's the reason why nowadays most of the people prefer PPC to be used for construction activities. So this basically this Portland pozzolana cement is designed to be used in marine structures, sewers. Why marine structures? Because seawater attacks. In order to resist seawater attacks, we use it in marine structures, and for sewers, sewage disposal works, because the sewers will have a lot of chemicals in it, because it can be from industrial waste or from domestic waste. You don't know what type of chemicals are coming in the sewers. So, and also there are some harmful gases that are being produced, especially H2S, SO2. All those gases will be produced, and most of them are acidic, and these acidic gases can attack the basic thing, that's this calcium oxide, and hence if we remove the calcium oxide and replace it with pozzolanic materials which are having a better resistance to these chemical attacks, it will be better. And next, for hydraulic structures like dams, reservoirs, canals, and aqueducts, because it has lower heat of evaluation. For mass structures like bridge piers and thick foundations. So see, basically pozzolanic cement can be used anywhere. Nowadays, very few. When I don't know, I don't even know whether people use ordinary Portland cement. It has highly been replaced by Portland pozzolana cement, PPC. You can easily find Portland pozzolana cement. It will be written on your cement bags as PPC. And next is Portland slag cement. This is another type of cement which instead of pozzolanic material will add slag. So let us see what is meant by slag. So Portland slag cement is manufactured by mixing clinker, gypsum, granulated furnace slag in suitable proportions and grinding the mixture to get thorough mixture. Clinker, gypsum, and granulated furnace slag. Have you studied from where we are getting slag in your 10th standard, I guess? From where we are getting slag from? Furnaces. What was the name? From the machinery or the equipment used for the burning of and the production of iron ore. What was the name? I don't remember. Who are the people who have studied it recently? Can anyone point out? Blast furnace, right? Can anyone respond?
Yes, sir.
Okay. So as a result, it's actually a byproduct in blast furnace, and you all know there's a lot of steel production that's been happening, and the slag, that's a result or the byproduct or the end product, byproduct, not the end product, byproduct of burn blast furnace, and we will mix it in with ordinary Portland cement to make it as Portland slag cement. So earlier we had mixed pozzolana cement, pozzolanic materials like fly ash, volcanic ash, etc. Here in slag, we will mix blast furnace slag, and a thorough mixture is produced. And the advantages of cement are reduced heat of hydration, reduced permeability, better resistance against corrosion of steel reinforcement, increased resistance to chemical attack. So it is suitable for places where soil or water containing excessive amount of sulfates or alkali metals, alumina and iron, as well as acidic, particularly in marine environment. So basically, the properties are similar to pozzolanic, Portland pozzolana cement, and this Portland slag cement is also produced, but the amount of this Portland slag cement produced is less compared with that of Portland pozzolana cement, because this fly ash is actually available in abundance, but this blast furnace slag is not that available. Still, we can find Portland slag cement even in our local uh, cement stores. If we ask them for slag cement, Portland slag cement, they will give us. So basically, what happened is like this Portland slag cement is not common for construction activities in our place, but for some engineered or some designed construction activities, they will use Portland slag cement because they know how to work with it. But our local masons, they doesn't have an idea about this water cement ratio, so they might have worked years. They might have a lot of years experience, but the cement that they are comfortable with might be either ordinary Portland cement or pozzolanic Portland cement. This They might not be much familiar with this Portland slag cement. So at many times, what happens is like they won't get this water cement ratio correct. Sometime the water might get the water cement might ratio might get uh, increased, or might be decreased. Most of the times they won't get the correct water cement ratio. Why? Because they are not experienced with the properties of Portland slag cement. Always there will be a decrease in the water content to be added for Portland slag cement. But people working in local conditions, the local masons might not know that, and they will add more water into that. And what happens is like the mixer will get of no use. It won't be a uniform mixture. So this is the thing. And this slag cement, what happens is like nowadays we are using this slag cement for not so important works, because not because the cement is bad. Why? Because people don't know how to mix it properly. So that's the reason why mix it with water properly. That's the reason why we use this cement for concrete works where there are less important, like flooring or maybe uh, some other works, small petty works. We won't generally use this thing for structural components like slab, beam, columns, etc. Because not because the cement is bad, but because people are doesn't have that expertise to handle with this type of cement. If we approach any masons, uh, they don't know whether it's slag cement or pozzolana cement. They don't know what type of cement we are giving them. So they will just mix the amount of water that they have been doing over the years, and that mixture won't get correct. So that's the thing. So basically, why we are using this Portland pozzolana cement is because we want to reduce the heat of hydration. That's the heat. That's the name of the heat that's been produced when you mix cement with water. The heat produced is known as heat of hydration. So this is a heat that we need to reduce for mass concrete works. Even for small concrete works also, if the heat is beyond limit, it can lead to cracks and all those things. So we should be careful while mixing. So this is the type of cement, and there are some other type of cement like colored cement. So these cements are obtained by adding pigments with ordinary Portland cement or white cement. The amount of pigments should be within 5 to 10%. So we will add some pigments, what depending upon the color that we require. So there are some different types of things like chromium oxide will be green in color. So if you want to get a cement which is green in color, we'll add chromium oxide. for some ornamental works or other aesthetical purposes, we'll have to use this colored cement. You might know this red oxide that people used to finish the floors in olden days. In olden days means even 10 or 15 years ago, it was common practice to use red oxide as flooring finish. But nowadays, I don't think many people have shifted to ceramic tiles because of the ease of construction and also the speed. It is having a much speed of construction. Since the labor charges have increased, we want to finish the works as soon as possible because we can't wait, give workers a lot of money as the number of days are progressing. So this iron oxide, red oxide cold finishes are no more constructed in most cases. So chromium oxide, if we add chromium oxide, we'll get green cement, cobalt, blue iron oxide. If you add iron oxide, we'll get brown, black, red, yellow, depending upon the percentage. So whatever it should be within that 5 to 10%. Only then maximum 10% is the limit. Beyond that, it can affect the properties of cement. Next is manganese, black, brown, carbon pigments. We want black oxide, or those things. So colored cements are sold in market under patented names of Snow, Wondersum, Rainbow, etc. These are used for floor finishing works and plastering of walls. Also used for decorative works, used for manufacturing of tiles and cast irons, etc. So there are some other. Still there are different types of cement remaining. So before that, I'll just finish with your attendance. I think I've called until Maria Manoj, right? So Malavika Muralidharan,
Present, sir.
Karthik Shiva,
Present, sir.
Joseph Agis,
Present, sir.
Joel Jos, Joel Jos, Jishnu P. Joel Jos is present. Jishnu P.
Present, sir.
Irene Teresa,
Present, sir.
Harsha Muralidharan, Harsha
Present, sir.
Muralidharan, Gokul
Present,
Sunil,
sir.
Present, sir.
Fatima Shana,
Present, sir.
Elsita Jos,
Present, sir.
Dia Georgian,
Present, sir.
Dilna P.
Present, sir.
Dalvin Jos, Dalvin
Present,
Jos,
sir.
Nibun Das,
Present, sir.
Basim. Is Basim present? Okay. So I've called Adulya's attendance, right? So computer science is over. Now we will move on to ADS. ADS Deva Nair.
Present, sir.
ADS Deva Nair. Hamna Rafiq.
Present, sir.
Jashin Simon.
Present, sir.
Kiran Prasad.
Present, sir.
Marwa Abdul Rasaq.
Present, sir.
Mazin Murshid. Mazin. Okay, Mazin present. Mohammad Zain Rafiq.
Present, sir.
Mantaj Vijayan.
Present, sir.
Navinita P. Nambiar.
Present, sir.
Vida Ghafoor.
Present, sir.
Rose Benny.
Present, sir.
Sharon Joseph.
Present, sir.
Shamit.
Present, sir.
Nehal Vinod.
Present, sir.
Saurav.
Present, sir.
Stephanie G.
Present, sir.
Taha Mohammed. Taha Mohammed present. Talha Anas. Talha Anas.
Present, sir.
Vaibhav Rajesh. Vaibhav present. Vaishak,
Present, sir.
Vishnupriya,
Present, sir.
Harsha Anil,
Present, sir.
Alan Thomas,
Present, sir.
Alana and John,
Present, sir.
Amrita Pradeep,
Present, sir.
Andrea Jason,
Present, sir.
Austin Manuel, Austin Manuel, Austin, Camagils,
Present, sir.
Chandana Rajivan,
Present, sir.
Christina Rose,
Present, sir.
Denny Thomas.
Present, sir.
Okay, so we will continue with our class, and we had discussed about the type of cement, and before that, I've actually submitted your first internal marks, and if anyone has any issues with that, please report me. Uh, like earlier, many like other teachers have told you, don't report with like half mark, 1 mark, just like you are in school. So you are in you'll be graduated in a few years, and you need to know that don't bargain for marks, and no one will entertain that, whoever it is. So if you have any concerns regarding your internal, where you have you didn't know how to answer some questions, all those things, you didn't know how much you should write down, should you explain it much more than that you have written, and if you have any other concerns, you can ask me or can mail me, that's better. So have you seen your marks, internal marks? Can anyone respond from both the classes, any of the representatives? Computer science, who is the representative? Computer science.
Sir.
Neha,
Yes,
have
sir.
you seen the internal marks?
No, sir.
You haven't seen your personal internal marks.
No.
Actually, I've submitted it. Just check, and if it's still not showing, just inform me. And for
Okay,
ADS,
sir. Seen,
ADS,
sir.
okay,
It's there.
okay. So we have been discussing about the type of cement, and we have finished Portland slag cement and colored cement. Next is the hydrophobic cement. So hydrophobic, you know what's in the hydrophobic. It should resist water or any liquids. So ordinary cement clinker is grinded. This IS specifications you can leave. It's not necessary. You need to remember this IS specifications. I just gave it for a reference for you. You need not study this IS 8040, etc. No one is going to ask you. So this just the function and where it is used. You need to remember those things. So ordinary cement clinker is grinded with water repelling shielding form substance. Might be some oleic acid or stearic acid, etc. And this material protects each grain of cement from the effect of moisture during storage and transportation. Properties of this cement are similar to ordinary Portland cement, except that it contains a small quantity of air bubbles. So this will have a small quantity of air bubbles in it, since each uh, grain of cement is coated with this kind of hydrophobic material. So other film forming materials like pentachlorophenol or calcium oleics are used for making this cement. Uh, Cement is also called as water repellent cement. This manufactured under trademark Aquacrete is used for watertight conditions predominant. So where we need some watertight conditions, where it is not at all recommended uh, for the external penetration of water from the external side, we will use this kind of hydrophobic cement, especially underwater concreting, all those things. It's necessary to use hydrophobic cement so that this water might not enter our structure. So this is the reason why we use hydrophobic cement. Next type is expansive cement. So ordinary Portland cement shrinks during setting and drying. So what happens is like the volume of concrete or cement mixture will shrink as a result of setting and drying. So when as this cement mixes with water and reacts with water, and after drying, what happens is like the volume will get reduced. That's known as shrinking of cement. That shrinking can cause some cracks in our structure. So this expansive cement suffers hardly any change in volume during drying. So that's the reason why we are using expansive cement. So expansive cement is manufactured by mixing 8 parts of sulfur aluminate clinker with 100 parts of Portland cement, 15 parts of stabilizer. So in order to reduce the change in volume, we'll be using expansive cement. So this type of cement is useful in machine foundation and cement grouting in pre-stressed concrete ducts. It's also used for concrete repair works. So in the repair works, what happens is like if there's some crack, we will use this expansive cement to close that crack. So what happens is like even after setting, that cement volume won't get reduced and the crack will be fully closed. Otherwise, what happens is like if that crack is closed with ordinary cement, after some days when the cement get dried, there will be some space in between that crack, in between the place where we have done that repair work. So that's the reason why you're using expansive cement. You need to understand that the reduction volume won't be there in the case of expansive cement after it reacts with water and after some days. So next is the acid resistant cement. Yeah.
Sir, hosting present ആയിരുന്നു പോലും ഓന് നെറ്റ് കട്ടായിട്ട് പോലും പ്രസന്റ് പറയുന്നു.
What's the attendance? Okay.
Sir, I got just disconnected when you were calling the
Yeah,
attendance.
no problem. I have marked attendance. So the types of cement. This is acid resistant cement. You all know where it is used. The basic function is to resist the acid attacks. So materials like quartz, sodium silicates, etc. as added to ordinary cement, and it is used for construction of acid-resistant floors in factories. In some factories, we need some construction activities where acids are produced or some chemicals are produced. We will use this cement for the construction of floors or walls in such cases where it is required to resist acid attacks. So there are some cements happening, and all those things we will discuss in the next class. And with that, we'll conclude this cement and its properties. So we were supposed to finish this cement by the end of this class, but we were not able to do that because we had a quick revision about the things that we have discussed in the previous class. So next time, with the next class, we will be able to conclude the type of cement, and we might be able to start the next topic. So thank you all. You can leave now.